Welcome to Solving Quadratic Functions by Graphing. Please make sure to take notes while I'm teaching in the video, pausing as often as necessary, and every time the video arrives at a you try, pause, attempt the problem, and the solution will be shown when you press play. In this section, we'll cover the following items. Let's review some quadratic vocabulary. We've got our vertex, we've got our axis of symmetry, our y-intercept, and our x-intercepts. And we're going to be talking a lot about x-intercepts today, and we're going to be using the word zeros, roots, and solutions. Just really quickly, let's double check that this is the vertex here. 3, 1. The axis of symmetry is x equals 3. There are no real zeros here. It does not hit the x-axis. And the y-intercept is 0, 7. If you're not sure how I got those answers, please go back to the video, Graphing Quadratic Functions. There are two types of quadratic functions. We've got our standard form, and we've got our vertex form. Now, standard form, you can easily find the y-intercept and the shape, but these require a little bit of work. With vertex form, we can easily find the shape, the axis of symmetry, and the vertex, but the y-intercept requires a little bit of work. Now, how do we solve quadratic functions? Well, let's think back. How did we solve linear functions? Well, we would just draw an equal sign line and solve the problem. But quadratic functions, it's not so easy. If I was to do that, I wouldn't really be able to get the x's alone. I can't combine these. I'm not really sure what to do. So for quadratic functions, we're trying to find the value of x when y is 0. So when you're asked to solve a quadratic, you're looking to find the x-intercepts, but usually they call them roots, zeros, or solutions. So we need to set y equal to 0 if we're looking for an x-intercept, and these are the three methods to solve quadratics: graphing, factoring, and quadratic formula. When solving quadratics, three things can happen. You can have 2 zeros, 1 zero, or no real zeros. It can look like this on a graph. The 2 zeros are the 2 points where it hits on the x-axis. The 1 0 happens to be the vertex, or there are no real zeros. It will never cross the x-axis. So let's go ahead and solve quadratic functions by graphing. Remember, solving means to find the x-intercept. So when we're solving by graphing, we're looking where does it hit the x-axis. We'll do 2 problems together, and then you'll do 2 on your own. So solve the quadratic function by graphing. So we have what kind of equation here? Well, this is a standard form equation. So we've got a is 1, b, c. So we can easily identify that the shape of this graph goes like that. We also can see our y-intercept pretty quickly. That's our c value, 0, 2. What requires more work with the standard form is the axis of symmetry. To find the axis of symmetry, we apply the formula, the opposite of b, over 2 times a. So we get x equals 3 over 2. Next, we're going to find the vertex. That would be 3 over 2. And then we need to take this 3 over 2 and plug it in for x to find our y value. So that is y equals 3 over 2 squared minus 3 times 3 over 2 plus 2. Take a moment, pause the screen, and type it into your calculator. You get negative 1 over 4. Now we're graphing, so I'm going to change those into decimals here. We get 1.5 and negative 0.25. All right, let's go ahead and graph this. So our y-intercept is 0, 2. Our vertex is 1.5, negative 0.25. And this is our axis of symmetry. Now remember, we're trying to solve. We're not just graphing here. It's not like I just want to connect this into a parabola and call it done, but I can do a couple things here. I know that's like 1.5, that's 1.5. So I know that the shape of this parabola looks like this. However, I am not sure where exactly it's hitting on the x-axis, and that is what solve means. But I can take a guess at what I think, and I can plug in to check. So it looks like it's going to hit at maybe x equals 1 and x equals 2. So let's give it a try. At x equals 1, we'll try, that would be 1 to the second power minus 3 times 1 plus 2. what happens? We get y equals 0. So x equals 1 is one of our zeros. We can use symmetry to see that it's half away from the axis of symmetry, so 2 must be our other 0, or you can plug in 2 as well. So the solutions to this quadratic function are x equals 1 and x equals 2. We'll do one more. Solve the quadratic function by graphing. Well, here's the problem. We need to get this so that it's set equal to 0, because solve means find the x-intercepts. So we'll add 4 to both sides. And now we get 0 equals negative x minus 1 squared plus 4. So what kind of form do we have? We have vertex form. So looking at our A term, we can see that the graph is going to point down. In vertex form, we can easily find the vertex. It's the opposite of the inner number and the outer number. And the axis of symmetry is that x value of the vertex. More difficult is finding that y-intercept. That's 0, and then we have to plug that in. So let's plug in 0 to find our y. So you can type this into your calculator really carefully, or you can do it by hand. You get 3. All right, let's graph this problem. So our vertex is 1, 4. Graph our axis of symmetry here. And our y-intercept is 0, 3. We can mirror this to the other side. We get a point at 2, 3. Now, we want to be careful when we graph. We know that it's going to go down. But where is it going to hit? I know that it's not going to hit at 2 because there's already a point there, or at 0, or at 1. So where might it hit next? Well, we can plug in to see. Remember that the objective is to see where is it going to hit that x-axis. So let's plug in 3 and see what we get. So that's negative 3 minus 1 squared plus 4. Negative 2 squared plus 4. Negative 4 plus 4 is 0. That's what we're looking for. So we know that it's going to hit right there at x equals 3. Now let's use mirroring to figure out the other point. So we're 1, 2 away. So that's 1, 2 away. So the other intercept is x equals negative 1. You can always check this value, plugging it in to double check that you are correct. And now you guys will try 2 problems on your own. Press play when you're ready to see the solutions. The first problem and the second problem. So now, can you always solve quadratics by graphing? So let's take a look at this problem here. Solve the following quadratic by graphing. I went ahead and graphed this in Desmos, and this is what happened. This 0 is fine. I can see that pretty clearly, but this one is not giving me an exact answer. When that happens, we need another method to deal with this, and that method is going to be factoring or quadratic formula. So that concludes solving quadratic functions by graphing.